federated one-shot learning. So in federated one-shot learning, the goal is to learn from only one example per class at each client. The challenge lies here in aggregating knowledge from different clients with limited data. So in federated one-shot learning, the goal is to learn from only one example per class at each client, right? So mathematically, if we want to give, so let's say that Ti be the data set at client I, the goal is to train a global model GM using only such D1, D2 and so on Dn, each having one sample per class k classes, while trying to learn from one classes along with minimizing the chances of overfitting. So again, federated one-shot learning addresses data scarcity by aggregating knowledge from various clients, resulting in a more robust global model. So basically here the federated learning with one-shot learning trying to solve the challenge, or it is trying to address data scarcity by aggregating knowledge of models trained from different clients, knowledge of models trained from data sources at different clients, resulting in a more robust global model. So basically, this type of federated one-shot learning is useful in medical imaging, where medical institutions contribute limited patients' data to collaboratively build a model for diagnosing rare conditions. So it can be applied in medical imaging applications, where the clients here are the hospitals, where the clients or hospitals contribute limited patients' data to collaboratively build a model for diagnosing rare conditions or diseases. That's pretty much about federated one-shot learning. Then We have federated few shot learning, federated few shot learning paradigm. So in federated few shot learning, similar to one shot learning, here the aim is to focus on learning from small number of examples per class. So it's like an extension of one shot learning. Instead of giving one sample per class at client, we have small number of examples per class across clients. We have small number of samples per class across clients, and everything else remains the same. So federated few shot learning enhances the model generalization by aggregating again information from clients with diverse few shot data sets. So it tries to enhance model generalization by aggregating information from clients with diverse few short datasets. So coming to the application, federated few shot learning is applicable in personalized recommendation systems where different clients contribute their limited user item interaction for interaction data for improved recommendations. So basically it can be applicable in scenarios like applicable to personalized recommendation systems where different clients contribute their different clients contribute their limited user to item interaction data for improved personalized recommendations. That's pretty much about federated one shot learning. Then we have something called federated continual learning, which is again a research area. So in federated continual learning, mainly it tries to address the challenge of learning new tasks over time while preserving knowledge of previously learned tasks across clients. So continual learning is a very well-known paradigm in machine learning. Now extending it to federated learning. So basically it addresses the challenge of learning new tasks over time while preserving the knowledge of previously learned tasks across clients. So mathematically, let Ti denotes a task faced by client Ci over time. So Ti is denotes the tasks faced by client Ci over time. Now the goal is to develop a global model that can perform well on new incoming tasks. Union I is equal to 1 to n Ti. So again, why federated learning is required? Federated continual learning enables clients to collectively learn and adapt to new tasks without sharing the historical data, fostering a lifelong learning capabilities. So here FL with continual learning enables clients to collectively learn and adapt to new tasks without sharing any historical data and fostering a lifelong learning capabilities. And coming to the application domain, federated continual learning is valuable in robotic systems where different robots in diverse environments learn and share new skills with each other. So application robotic systems where different robotic clients in diverse environments learn and share new tasks continually in a continual fashion with each other. So this is pretty much a brief about federated continual learning. Next we have federated contrastive learning. So in federated contrastive learning leverages contrastive laws to learn semantically meaningful representation across diverse clients. So it leverages contrastive laws to learn semantically meaningful information across diverse clients. So again, why federated learning? So federated learning with contrast learning promotes representation learning while preserving data privacy and reducing communication overhead. And coming to application domains, federated contrastive learning is useful in recommendation systems, again, where clients' preferences are captured in a distributed manner without sharing raw preferences. So recommendation systems again can be an application domain for the federated contrastive learning. Then finally, we have federated reinforcement learning. So in federated reinforcement learning, basically it enables agents in different environments to collaboratively improve their policies through experience by sharing only the policy information and while respecting the data. So it enables agents in different environments to collectively improve their policies through experience sharing while respecting privacy. So federated learning with reinforcement learning facilitates policy learning in decentralized environments without revealing sensitive environment details. So FL plus RL facilitates policy learning in decentralized environments without revealing sensitive environment details that they are working. So coming to application domains, multi-robot systems are one application domain where robots learn to cooperate and adapt in diverse environments while minimizing the communication overhead. So multi-robotic systems can be the application domain where the robots learn to cooperate and adapt in diverse environments while minimizing communication overhead. So that is pretty much about federated reinforcement learning and federated contrastive learning, federated continual learning, and federated one-shot learning, federated few-shot learning, and then federated zero-shot learning. So in this part we delved into a deeper understanding of what federated learning is in general and what all application domains it can cover. Basically it is interdisciplinary and can be applied to any application domains along with solving their challenges and while preserving the data privacy. And coming to task, federated learning can easily expand to any of the tasks like federated object detection, federated semantic segmentation, federated object tracking, federated generative AI, and so on. And coming to paradigms, federated, we have good federated research paradigms like federated zero-shot learning, federated one-shot learning, few-shot learning, federated continual contrastive learning, and then federated reinforcement learning. So I'll end this part here, and in the next part we'll try to learn the general challenges in a federated learning process along with each of the steps involved in the federated learning and the challenges involved in each process. Thank you.